assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So this problem wants us to take the combustion of octane, which is 2C8H18 plus 25O2, forms 16 CO2 plus 18 H2O. And all of these are in the gaseous state. And wants us to find the delta H of this reaction using bond energies and using delta H of formation, and then find the percent difference between them and explain which one is more accurate. And so the first thing we'll do is with bond energies or enthalpies. And so the way we do this is that delta H of reaction is equal to the sum of the H's of bonds broken minus the sum of the H's of bonds formed. And so referencing the previous page from our octane, since we have two of them and 18 CH bonds, we have 36 total CH bonds plus 14 total CC bonds. And then we have 25 oxygens, so we have 25 O double bonds. So these are our bonds broken. And then we subtract our bonds formed. We have 32 CO double bonds formed because we have 2 of these per carbon dioxide and we have 16, so 32. And then similarly with the water, we have 36 OH bonds. And that's because we have 2 per water and 18 waters, so we have 36 of those. So now we can plug in all of the values for those. We have 36 times 414. That is the bond energy of CH. Then 14 times 347 for CC. And then 25 times 498 for OO double bond. And then we subtract 32 times 799, which is the CO double bond. And then 36 times 464, the OH bond. And when we do this, that gives us 32212 minus 42272, which gives us negative 10,060 kilojoules. So this is our answer for using bond energies or enthalpies. Now we can use delta H of formation for these. And so the way we do this is that our delta H of reaction is going to equal the delta H of formation of the products minus the delta H of formation of the reactants. And so we'll start with the products. We have 18 delta H formation of H2O gas plus 16 times the delta H of formation of CO2 gas. And then we subtract the reactants. We have 25 times the delta H of formation of O2 gas, which is 0. And then we subtract the whole thing, so we'll add the 2 times the delta H of formation of our octane. And so when we do this, we end up with negative, I'll plug in the values first actually. So we have 18 times the H2O one is negative 241.8. The CO2 is negative 393.5. The O2 is 0, and the octane is negative 249.73. And so when we combine these and add them together and subtract, we get that the delta H of reaction using this method is negative 10149 kilojoules. And so now we have our two answers with our two different methods. And so in order to find the percent difference, we take the absolute value of one of our answers and subtract the other one, and then divide by the original. And we do absolute value here just so that we get a positive percent, and then we multiply by 100, but that gives us 0.88% difference. So there isn't that large of a difference here at all. It's less than 1%. However, using the delta H of formations is going to be more accurate, as the bond energies are based on the average bond energy of that bond. And so the delta H of formation is specific per molecule, whereas when it's specific per bond, it is not quite as accurate. So those are the final answers, and the delta H of formation method is more accurate.